Hello students, welcome to Shri Classes. Today we are going to study the conversions of solids, that is conversion of two or more solids to form another solid. See, very important is conversion of solids involves volumetric ratio constant, meaning whenever we melt two or more solids and create one more shape, then the volume of the solids before conversion should be equal to the volume of after conversion. The volumetric ratio remains constant. One example I can illustrate here. There are two spheres taken. Sphere 1 is of radius r1 and this sphere is of radius r2. If I melt both these things and mix together and then create one more shape which is in the form of a cone, then volume of sphere 1 plus volume of sphere 2 should be equal to volume of cone. I hope you understand. With this concept, let us start solving the numericals. That is from exercise 13.3. Example numericals you are requested to solve all, and exercise numericals will be taken up by me. So keep in mind, when the solids are melted and converted to different shapes and sizes, then the volumetric ratio remains constant. With this, you should be able to understand. So let us start solving numericals from exercise 13.3. Exercise 13.3. Here take pi equals 22 by 7 unless stated otherwise. The first question, let me see whether you can be able to see it clearly. Okay, I think so, you should be able to see. A metallic sphere, just a moment, I'll try to adjust a little bit font to 25%. I hope you should be able to clearly see. Yeah, this makes sense. First question, a metallic sphere of radius 4.2 centimeter is melted and recast into the shape of a cylinder of radius 6 centimeter. Find the height of the cylinder. There is a metallic sphere of radius 4.2 centimeter. The sphere is converted into a cylinder. How this is converted? A metallic sphere is melted and that has been converted into a different shape, that is cylinder. So volume of the sphere should be equal to volume of the cylinder. So let us solve this on the board now. Here, question number 1, you can see the diagram clearly. Sphere of radius r1 4.2 centimeter is melted and recast into a cylinder. And this cylinder, radius r2 here 6 centimeter, and let the height be h. Question is, what is the height of this cylinder? In order to find out the height of the cylinder, the volume of the sphere should be equated to the volume of the cylinder. So volume of sphere equals volume of cylinder. 4 by 3 pi r1 cube equals 4 pi r2 square h. Okay, r1 is the radius of the sphere, r2 is the radius of the cylinder. Okay, so and here pi and pi cancels, therefore 4 by 3 r1 cube, that is 4 by 3 r1 is 4.2, 4.2 into 4.2 into 4.2 equals r2 square 6 into 6 into h, and height is what we need to find out. Therefore height is equal to 4 by 3 as it is, then 4.2 into 4.2 into 4.2 divided by 6 into 6 is what I have written. So this is 6 ones are 6.7s are 6 ones are 6.7s are, and 3 ones are 3, and here 3 1.4s are 4.2. So what is that we are left here is 4 into 0.7 into 0.7 into 1.4. That's all. 4 into 0.7 into 0.7 into 1.4. So height is, if you work out, 2.74 centimeter. And therefore the height of the resulting cylinder is 2.74 centimeter. First, make a note of this one. Next is question number 2. Metallic spheres of radii 6 centimeter, 8 centimeter and 10 centimeter. These are 3 spheres of radii 6, 8 and 10 centimeter respectively. These are melted to form a single solid sphere. So the resulting shape is also spherical shape, sphere. Find the radius of the resulting sphere. So let us solve this on the board. So given to us over here are 3 spheres of radius r1, r2, r3, 6, 8 and 10 centimeter respectively. All these are melted together. All these are melted and added, and then a new sphere is created. So I can put plus here for your information, what is that is done is basically here this plus gives you this resulting sphere. That means individually these three spheres are melted and volumes are added, then the resulting sphere is created. Question is, what is the radius of this resulting sphere? So volume should be equated. Volume 1 plus volume 2 plus volume 3 equals V. What is V1, V2, V3? Volumes of these three spheres respectively are V1, V2, V3. And the capital V is the resulting sphere. So R1, R2, R3 are the radii of three spheres, and I am taking as capital R for the radius of the resulting sphere. You can also take R4, but generally capital letters are taken for the resulting things. Not mandatory, okay, it is up to you to decide. So that is R there. So volume 1, volume 2, volume 3 equals volume of the resulting sphere. 4 by 3 pi R1 cube, 4 by 3 pi R2 cube plus 4 by 3 pi R cube, R3 cube equals 4 by 3 pi capital R cube. 4 by 3 pi is common both on the left hand and right hand side, that I have taken common here. R1 cube plus R2 cube plus R3 cube equals so and so. This 4 pi by 3 and 4 pi by 3 cancels. Remaining is this remaining part, R cube equals so and so. Substitute the values R cube, R1 cube, R2 cube, R3 cube, that is 6 cube plus 8 cube plus 10 cube equals R cube, capital R cube. And solve this one. 216 plus 512 plus 1000 equals R cube. 1728 equals R cube. Now what is that you can do here is generally this you have to factorize. How do you find out this R now? It is a cubic root I have to take. So how to find out is you factorize this one. After factorization, if I am able to arrange all the factors in terms of triplets, it is 12 into 12 into 12. You got it? So R cube equals 12 into 12 into 12, which is nothing but 12 cube. So R is equal to cube root of 12 to the power 3. Nothing but cube root of 12 into 12 into 12. So if it is a cube root, the triplets will come out once, and therefore 12 has come out of the root here. Therefore R is equal to 12 centimeter. इसको units लिख देंगे, इधर ही लिख देंगे 12 centimeter. And therefore finally the answer, radius of resulting sphere is R equals 12 centimeter. Clear? So make a note of this. Question number 3. A 20-meter deep well with the diameter 7 meter is dug, and the earth from the digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. Let us solve this. Here, what is that is equated volume wise? Just have a look at this. This is a well, and well is in the form of a cylindrical shape, and diameter is 7 meter, therefore radius is 7 by 2 meter, and the depth of the well is given as 20 meter. So earth is dug from this well. When the earth is dug from this well, the quantity of earth dug is equal to the volume of this cylinder, and that earth is spread evenly in the form of a platform whose dimensions are length is 22 meter and breadth is 14 meter. We need to find out the height of this platform. So height, how to find out that? Volume should be equated. Volume of the earth dug should be equal to volume of the platform. Volume of earth dug is equal to volume of platform, and volume of earth dug is nothing but volume of the cylindrical well. So volume of the cylinder should be equal to volume of the cuboid, because platform is in the shape of a cuboid. So volume of the cylinder is pi r square into h equals L into B into h is the volume. In order to distinguish between the height of the well and height of the cuboid, I have taken a small h as the height of the well and capital H as height of the platform, which is a cuboid. Okay. So pi r square h is equal to LBH. Put the values. 22 by 7 into r is 7 by 2. 7 by 2 into 7 by 2 into height. Height is 20 meter equals L is 22 meter into breadth is 14 meter into height, and this height we need to find out. So if you look at This 22 and 22 cancels, 7 and 7 cancels, 2 ones are 2 tens are 20, so 2 ones are 2 fives are 10. So remaining out of this here is 7 and into 5, which is 35, and take this 14 below, so that you will get the h. H is equal to 35 by 14, which is 2.5 meter. So is it clear? So height of the platform is 2.5 meter. Please make a note of this. Question number 4. A well of diameter 3 meter is dug 14 meter deep. It is similar to the previous question which we had done, but slightly different. Let us read that question first. A well of diameter 3 meter is dug 14 meter deep, and a well of diameter 3 meter is dug 14 meter deep. The earth taken out of this out of it has been spread evenly all around it, all around the well, in the shape of a circular ring of width 4 meter to form an embankment. So that is called an embankment. Embankment matlab, you know, all this mud, the earth which is dug, the mud which has been taken out, that is surrounding the given well of diameter 3 meter. So that it is also a kind of platform, we can say. Embankment, it is a kind of platform surrounding a particular well. Okay. So find the height of the embankment. So here there are two aspects, a well and the embankment. Volume of the earth dug out of the well should be equal to volume of the embankment. Let us draw the diagram so that it is very clear to you. This is the diagram here. This is the well of diameter 3 meter, and it is dug up to depth of 14 meter. The mud which has been taken out, it is evenly spread to form an embankment. You got it? It is formed to form an embankment. So this embankment is nothing but here, it is this earth is surrounding this well with a height h2. So this is something like a platform only which has been made around the well. What are the dimensions here? Diameter of the well is given, height of the well is given. Fine, we can find out the volume. For this, you know, the width of the embankment is given. The width means this width, this width, this width is 4 meter. So how do you find out the radius, outer radius? Inner radius of this embankment is equal to the radius of the cylinder, which is R1, 1.5 meter. Outer radius is equal to inner radius plus this width 4 meter. So R2 is the outer radius, which is equal to R1 is the inner radius of the well. This is the inner radius here. Inner radius, or from here to here the inner radius, plus this 4 meter gives you the outer radius. 1.5 plus 4, which is 5.5 meter. So for this circular embankment, I have R1 equals 1.5 meter and R2 equals 5.5 meter, and H2 is the height of the embankment. Now volume of the earth dug is volume of the cylinder, because the well is in the form of a cylinder. So V1 is equal to pi R1 square H1, which is pi into 1.5 into 1.5 into 14, so many cubic meters. I have not worked out, because anyway we are going to relate the volume, equate the volume, and certain things will get cancelled out. How do you find out the volume of the embankment? Volume of the embankment is equal to area of the circular ring into height. Where is this circular ring? This is the area of the circular ring. So you are able to understand? This is area of the circular ring into height gives you the volume of the embankment. How do you calculate the area of the circular ring? Outer circle area minus inner circle area, that is pi R2 square minus pi R1 square. So area of the circular ring is pi R2 square minus pi R1 square. Pi you take common, R2 square minus R1 square into height. Height is h2 there. So this entire thing gives you the volume of the embankment. So pi into 5.5 the whole square minus 1.5 the whole square into h2, because we have to find out h2. So many cubic meters. Now in order to find this height h2, volume should be equated. Volume of the cylindrical well is equal to volume of the embankment. So substitute the values here. Pi into 1.5 into 1.5 into 14. This is equal to pi into 5.5 the whole square minus 1.5 the whole square into S2. Pi cancels here. This you work out, it is 31.5. Now this is, I have worked out as a square minus b square here. This is in the form of a square minus b square, and which is nothing but a plus b into a minus b. That format I am taking here, because this is, I am simplifying as 5.5 plus 1.5, 5.5 minus 1.5 into S2. So 31.5 equals, this is 7 here and this is 4 here, 7 into 4 S2. So finally S2 equals 31.5 divided by 7 for the 28, that is divided by 28, which is 1.125 meter height. So therefore finally you can write down height of the embankment is S2 equals 1.125 meter height. Clear? Quite simple, not much of a difficult. But remember, diagrams everywhere, I am giving utmost importance for the diagrams. If your diagrams are good with all enumerated values of radius, height, etc., the dimensions, then you need not write over here, for cylinder so and so, for platform so and so, all that is not required. Please skip. So directly what you can do is, from this diagram, substitute the values, because already you are populating the values of different parameters in the diagram itself. So directly you can substitute and work out in order to save the time. Anyway, you have to draw the diagrams. Without diagrams you cannot solve these numericals, and diagrams should be very clear, big enough and very clear, and also dark enough. So ensure that you do, or you follow all those methods. So I hope you are able to understand. So make a note of this. Question number 5. A container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. So there is a container which is a cylindrical shape, and diameter is 12, so radius is 6 and height is 15 centimeter given to us. The ice cream is to be filled into the cones of height 12 centimeter and diameter 6 centimeter. So that ice cream is to be filled into cones having a hemispherical shape on the top. A cone with a hemispherical top on the hemispherical shape on the top. That is how we have to fill up the ice creams in the cone. Find the number of such cones which can be filled with ice cream. So let the number of cones could be n. Okay, fine. So let us solve this on the board now. There is a cylinder, and this cylinder is filled up with ice cream, and this ice cream is to be transferred to cones, and it is a cone with a hemispherical shape on the top. How do you fill up the ice cream? Basically, it is to be filled up in the cone with hemispherical shape on the top. And how many such cones will be formed is the question. How many such cones will be filled up? Let the number of cones to be filled up be n. You got it? So a cylinder should be, the ice cream from the cylinder is to be filled up into n number of such cones. Now let us concentrate on the dimensions. Diameter is given, radius is 6 centimeter here. Diameter is 12 centimeter, radius is 6 centimeter. Height h1 is given as 15 centimeter. With respect to cone, R2 is, diameter is 6, therefore 3 centimeter is the radius. Height of the cone 12 centimeter. For sphere, the radius is 3 centimeter, which is the radius of the cone itself. And let the number of cones be n here. Now here we have to match the volumes. That means this cylinder should be equal to, the cylinder volume should be equal to n times the volume of the cones. Therefore volume of the cylinder is equal to n times volume of the cone plus volume of the hemisphere. Yeah, I said only cone, no, it is not, it is the entire volume. N times volume of the cone plus volume of the spheres basically. Because ice cream is in the form of a cone with hemispherical top there. So look at the formula pi r1 square h1 that is the volume of this one, is equal to n times volume of the cone is 1/3 pi r2 square h2 plus volume of the hemisphere is 2/3 pi r2 cube. Clear? Now fill up the values. Pi r1 is 6 square into height is 15 centimeter, which is equal to n times, take out the pi here, into bracket r2 square h2 by 3, r2 is 3 centimeter, so 3 square into 12 divided by 3 plus 2/3 pi already has come out here, r2 cube. What is r2? 3 centimeter cube. Now this is 36 into 15 is equal to n times, this is 1313 goes here, 3 remains, 3 into 12 36, and 1313 goes here, 3 square is 9 into 2 18. So 36 into 15 is n into 54. So if you work out, number of cones is equal to 30/3, finally 10. So number of cones with which the ice cream is filled up is equal to 10 cones. Okay, I hope you understand this. Make a note of this. Next is question number 6. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter. See, one important aspect to be concentrated over here is the units of measurements. Sometimes you may get centimeters, sometimes you get millimeters. If the homogeneity is not maintained, meaning the same units are not maintained, then you will get wrong answer. The most important aspect here is homogeneity of units when we are equating it. Okay, so let us solve this on the board now. Here in terms of the diagram, if you look at, this is what it is. Let n be the number of silver coins which are to be melted to form a cuboid. Dimensions of the silver coin are, diameter is 1.75, so radius is 1.75 by 2 centimeter. Thickness is given as 2 millimeter, and therefore that is the height here, which is 2 millimeter converted to centimeter, 0.2 centimeter. All the dimensions over here are in terms of centimeter. Next, if it is converted, if n coins are melted and converted to cuboid, what are the dimensions? Length is 5.5 centimeter, breadth is 10 centimeter, and height is 3.5 centimeter. Yes, homogeneity of units is maintained on both the sides with respect to populating the values of the radius, etc., the values of the shapes. So n into volume of silver coin, n into volume of each silver coin is equal to volume of cuboid. N into, this is a cylindrical shape, so pi r square h should be equal to L into B into h. Fill up the values. N into 22/7, and what is radius? 1.75/2. So 1.75/2 into 1.75/2 into 0.2. This 0.2 is the thickness, which is height here, is equal to 5.5 into 10 into 3.5 LBH. So n equals, take all this, transpose it by cross multiplying, you get 5.5 into 10 into 3.5 into 2 into 2 into 7 by 22 into 1.75 to 1.75 to 0.2. Now, in order to avoid the decimal points, it is preferable to express them as integers and take the sum of the denominators upwards. What I have done here is 5.5 into 10 is 55, 3.5 into 2 is 7, and 2 into 7, as it is 2 into 7 I have written. Okay, divided by 22, this 1.75 is written as 175 by 100, so 100 goes up. This is also written as 175 by 100, once again 100 goes up, and this 0.2 is written as 2 by 10, and 10 goes up. Now it is simple. Here you can see 2 ones are 2 11s are 22, 11 ones are 11 5s are 55, then 7 ones are 7 25s are 7 ones are 7 25s are, okay, then 2 ones are 2 5s are here, 25 ones are 25 4s are 25 ones are 25 4s are. Finally, if you simplify yourself, you will come to that 5 into 4 into 4 into 5 on the numerator. That's all. Denominator, everything is cancelled, which gives me 400 numbers. That means in order to convert n number of such silver coins to form a cuboid of this dimension, we equated n times volume of the silver coin is equal to volume of the cuboid, and finally got the number of coins to be melted is as 400 silver coins. Clear? So make a note of this one. Question number 7. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. So cylindrical bucket dimensions are given, height and radius. This bucket is emptied on the ground and a conical heap is formed. A conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So a sand is taken in a cylindrical bucket and it is emptied on the ground to form a conical heap, and the conical heap's height is given as 24 centimeter. We need to find the radius of the heap, and also there is one more question, slant height of the heap is also to be formed. So let us solve this on the board. So here it is a cylindrical bucket. This is a bucket, okay, and it is emptied on the ground to form a cylindrical heap, conical heap. Okay, this is how it looks. So R1 H1, R2 H2 are the dimensions, 18 centimeter, 32 centimeter here, and R2 we have to find out, where H2 is given as 24 centimeter. So in order to find this one, volume need to be equated straight away. It's a simple question. Volume of the cylindrical bucket is volume of the conical heap. So pi R1 square H1 is equal to 1/3 pi R2 square H2. Substitute the values over here. Finally you get the radius R2 as 36 centimeter. What is that? Radius as 36 centimeter. That is, radius of the conical heap of the sand formed is 36 centimeter. Now slant height, how do you find out? The slant height for this is L, which is equal to under root of R square plus H square. That is the formula, R square plus H square. So slant height is equal to R2 square plus H2 square. Got it? So which is under root of 36 square plus 24 square, and if you work out, it is giving us 12 root 13 centimeter. Okay, so make a note of this. Question number 8 and 9 are related to flow of water through pipes or canals, for which I have to give a brief introduction about that one. That is, how to calculate the flow of water through pipe or a canal or different cross sections. So let us study that on the board, and then it is easier for us to solve these two numericals. Okay, so come, let's study now. Now we'll study the flow through the pipe. I think a camera has been adjusted to capture this entire thing. Hope you are able to see very clearly. Say flow through pipe, even though I mention over here as a pipe, this circular pipe can be a rectangular pipe, or it can be a channel also. Channel means it is a U-tube channel through which, or a U-shaped channel, or a canals which we call, through which the water flows. So what is the significance of this flow through pipe in time t? That is very important. That means, let me consider a circular pipe over here, and let the water flow through this pipe at a speed of x kilometers per hour. And here there is a collection tank. So in time t, what is the volume that is collected in this collection tank is what I would like to know in the form of a particular formula. So here, just a moment. Yeah, now for this pipe, it is a circular cross section. Basically, cross section means, this is a pipe of circular cross section. What is cross section? If this is a pipe, if I cut this horizontally and remove this part, this is what you are going to see. What is the cross section of this? This is called a cross section. It is a circular cross section, isn't it? I hope you should be able to see that. This is a circular cross section. Okay. Now, in this pipe, I am considering a water flow, and the speed of water is x kilometers per hour. Let A be the area of the cross section. You can calculate the area based on the particular cross section, that is circle or a square or a rectangle, or for that matter a canal. You should be able to calculate the cross section area. Now, how much water is collected in this tank in time t? In time t, what is the water collected? In time t, what is the water collected? The volume of water collected in this tank is what we have to find out. Simple formula. See here. Speed of the water into cross section area into time gives you the volume of water collected in the tank. What is that once again? Speed into cross section area into time gives you the volume of water collected in this tank. This is one formula you should know. Now, how do you confirm that this is speed into cross section area and time should give you volume? The LHS and RHS units of measurement should match, isn't it? Now, if the speed is meter per second, that is speed is meter per second, into cross section area is square meter into the time is hours. It is time can be time is hours basically. Actually, I consider homogeneity of units as seconds only. So in this case, if it is second, so second cancels, square meter into meter gives you cubic meter, and therefore multiplying speed with cross section area and a time is nothing but the volume of water collected in this particular tank. Why we have to know this formula? The question sometimes asked will be, water is flowing at the rate of so and so kilometers per hour. The radius of the pipe will be given to you, and find out the height of the water. Find out the height of the water in this tank, in the collection tank. If the cross section of this tank, all those details will be given to you in particular time. Say for example, if the water is flowing at the rate of 5 kilometers per hour, in 30 minutes, what is the quantity of water collected? Could be one type of question. What is the height of the water in the collection tank in 30 minutes? That could be another type of question. So in order to understand the volume of water collected in a tank, that is in the collection tank, through a pipe, we must know this formula. Now, note, it is important here the homogeneity of units should be ensured. Homogeneity of units means all the units of measurement should be in one particular type of units. You cannot club centimeter and meter and kilometers all together, and time in seconds and hours you cannot club together. You need to ensure the homogeneity, for which I prefer SI system of units. But again, it depends basically. Okay. So first of all, speed, generally we convert speed, if it is given as kilometers per hour, into meters per hour by multiplying by factor 1000. And cross section area, if the cross section of the pipe is circular, then the area is given by pi r square, in which case we should know the radius. If it is square, we should know one side, area will be a square. Here I'll write this is a, basically area is pi r square. If it is a square of side a, then area will be a square. If it is a rectangle of length L and B, then area is length and breadth. And suppose this is a channel over here. See, this is a channel, and this is how the water is flowing. If you know the height of the water through height of the water in a channel or a canal, also you can say, either a channel or a canal also you can say. Canal, if you know the height and breadth of the canal and height of the water that is flowing, you can calculate the cross section area as B into H. This is how. And conversion of centimeter to meter, area generally, you know, sometimes it will be given meters or square centimeter. Sometimes area will be in the form of centimeter square. If the units are centimeter square, and if I are following SI system of units, you should convert it into square meters by multiplying with 10 to the power minus 4. And similarly, time will be in minutes generally given to you, divided by 60, that is you have to, for example, 30 minutes, which is equal to 1 by 60, 30 by 60, divided by 60 to get into hours. So vice versa also, you can do that one by changing the suitable multiplying factor. So note is homogeneity of units should be maintained, and speed, conversion factor, area, different possibilities, and conversion factor for area, and time, how to convert it. This is one particular part. So this you have to note down very clearly, and you can expect one question from this. And sometimes, very most popular question which can be considered or which can be looked is, a water flowing through the pipe is having, or a water is flowing at the rate of so and so kilometers per hour, and this is a circular pipe of radius so and so, that will be given to you. Find out in 30 minutes the height of the water accumulated on the field if that water is released into the field. That will be the question basically. So in order to solve such numericals, this formula is most important. So I hope you have understood. If you have any doubts, you can discuss with me during the live session. So please make a note of this one. Question number 8. Before we solve this question number 8, I hope you have understood the formula of flow of water through pipe in given time. Okay, based on that, we'll solve these two numericals. Question number 8. Water in a canal 6 meter wide and 1.5 meter deep. So the cross section area of the canal, we can get it from this information. So water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? That means canal width is given to us, height is given to us, that is depth, area of the cross section of the canal is possible, speed of the water is given, and also time is given. So in 30 minutes converted to hours, volume of water through canal in 30 minutes is equal to volume of water collected on the ground basically with a height of 8 centimeter. So that is the given information. So let's solve this on the board now. See, the diagrammatic representation looks here. This is a canal here and water is flowing through the field. Water is flowing into the field. Speed of the water 10 kilometers per hour, and width of the canal is 6 meter, height is 1.5 meter, the cross section area is 6 into 1.5, and time given here, I'll write time here is equal to 30 minutes. Okay, water flows through this canal in 30 minutes. In 30 minutes, the water collected on the field is up to a height of 8 centimeter. Got it? If A is the area that is irrigated land, then the volume of the water collected over here is area into height, gives me the volume of water collected over the field. Okay, now the given information, see here certain conversions are there. Speed is 10 kilometers per hour, convert it into meters per hour, multiply it by 1000, that gives you 10,000 meters per hour. Time is in 30 minutes, convert it to hours by dividing 60. You have to divide the time minutes by 60 to get in hours. Cross section area of the canal, this cross section area, this is the cross section area. I hope you understand this. From here the water is flowing out. It is 6 into 1.5 square meters. Height of the water on the field is 8 centimeter. Convert this into a meter, which is divided by 100 gives you 0.08 meter height of the water collected on this land. What is the volume over here? Volume of the water collected, area into height, that gives you the volume of water collected on the field. What is the volume of water in time 30 minutes that is flowing through the canal? So volume of water in time t through canal is equal to volume of water collected on the land. What is the volume of water in time through canal? Speed into time into cross section area, that gives you area into height. Speed is 10,000, time is 30 by 60, cross section area 6 into 1.5, int is equal to a into 0.08. So here 30 by 60, this is 6 cancels, 0 0, 3 is left, 10,000 3 into 1.5 equals a into 0.08. So area is 10,000 into 3 into 1.5, that is nothing but 3 into 1.5 is 4.5. 10,000 into 4.5 divided by 0.08. See how I have done is 10,000 as it is into 4.5 can be written as 45 divided by 10. and this 8.08 can be represented as 8 divided by 100, that 100 goes up. So this is how I have simplified to eliminate the decimals over here. Finally this 10 and 10 cancels, 8 and 10 are left. If you simplify, you will get 1.25. so finally 10,000 into 45 into 1.25, if you multiply 45 into 1.25, you get 56.25 cubic meters, 56.25 into 10,000 cubic meters. Now I can leave at this stage also. Finally you convert this decimal into one number and represent it as cubic meters, but generally the areas are measured in terms of hectares. In that case, 1 hectare is equal to 10,000 square meters. So this is square meter area. Sorry, I have done this cubic meter. Okay, correct. What is that we have calculated? Area. Yeah. Sorry, this is square meter. Okay. Square meter. Why square meter? Because we are finding out the area here. Is it clear? This is square meter. Now this is 10,000 into 56.25 square meters. Convert it into hectares by dividing with 10,000 square meters. So this entire quantity is divided by 10,000, remaining is 56.25 hectares. So finally the area of the land that is irrigated when 8 centimeters of water gets accumulated on the land is equal to 56.25 hectares. Clear? So make a note of this one. I hope this is quite clear how to solve this numerical. Dear students, one more question is there, that is the last question, 9th question. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter in deep. If water flows through the pipe at the rate of 3 kilometers per hour, in how much time will the tank be filled? Water flowing through the pipe in time t is equal to water collected in the cylindrical tank. If you equate, you should be able to find out t. See, all this information is given. Speed is given, time you have to calculate, cross section area is given of the canal basically, because it is of pipe. It is of the cross section area is a circular cross section area because it is a pipe. The diameter is given, radius you can work out, cross section area of the pipe is pi r square. Okay, so this part speed is given, cross section area is given, time you have to calculate, and area, this volume of the water collected in the tank is, there is a cylindrical tank which is 10 meter in diameter and 2 meter in deep. So you know the volume collected in that tank. So water flowing through the pipe in time t is equal to volume of the water collected in the cylindrical tank. Apply that one and you solve yourself, you take it as a homework. Okay, so dear students, what we did here, exercise, this is 13.3. For this year you do not have the first term of a cone numericals, so exercise 13.4 I will be taking only during live session if some of you are interested, and therefore chapter number 13 and surface areas and volumes I have completed in all respects with almost all the numericals I have solved, and I request all of you to note down all these things properly and practice a lot. Okay, so this chapter is complete in all respects, and some optional are there. That optional questions I will be discussing during my live sessions. Okay, so with this we have completed this lecture and also this chapter. So thank you very much for watching. Thank you once again.